this first part will be a good review of what we learned last week, and then and kind of combining a whole bunch of stuff together here. Okay, so we're the two samples we're going to talk about today, or at least to start, are what percent of Grandview students versus what percent of Bexley students ate breakfast in the morning. Everybody with me so far? So here's what we know overall. At Grandview, the proportion of all students who ate breakfast is 75%. So I'm going to call that P sub G, using that G to just keep track of what's what here. And I know that the P for Grandview is 0.75. And then we're taking a random sample of 100 students from Grandview. So N equals 100 for Grandview. And if that's the case, can we talk about what the possible p-hats from that Grandview population might look like? Okay, if we all take a different sample of 100 students, are they all going to be 75%? No, because p-hat is a variable. It depends on which sample we got. We could all take samples and we'd all get a different sample. And so because samples are different, samples aren't perfect, we're all going to get different ones, yes? What can we say about the shape of our p-hats? Well, whenever we're talking about shape, our hope is that the shape will be approximately normal. Do you guys remember from last week, when will the p-hats be approximately normal? When what is greater than 10?
Mean and standard deviation.
No. We are going to use those formulas to talk about the center and the spread. It was so the normal happens when we have NP and N1 minus P are both greater than or equal to 10. Okay? So in this particular case, I would be doing 100 times 0.75, which is 75. And I would do 100 times 0.25, which is 25. So we can say approximately normal because both of those things are greater than or equal to 10. Everybody good so far? Now, the mean of the Grandview p-hats will be, what will the mean be? 0.75. The standard deviation of the p-hats for Grandview would be, we would do the square root of 0.75 times 0.25 all over 100. Square root of P, 1 minus P over N. Again, formulas are on your formula sheet. You don't need to stress too much about it.
Is that 0.75 and 0.25?
Mm-hmm. What are we getting? 0.043. Great. Okay. All right, so now we're going to switch over to Bexley. And so for Bexley, our sample size is 200. And our population proportion is 60. Okay, so will that be approximately number? That's what I said, approximately number. You guys know I mean normal, yeah. So we got 120 and 80. I think we're good. Okay, and for my mean of the possible Bexley samples, points standard deviation. I have no idea. 0.034, thank you. Okay. So I kind of want to draw a quick picture of what's going on here. So here are my Grandview p-hats. And what I'm going to do is I'm going to take away the Bexley p-hats. But what does that really mean? Okay, so now, let's say I go ahead and I randomly draw my samples, yeah? So my Grandview percentage is right here and my Bexley percentage is right here. Is it reasonable that this could be my sample for Grandview and this could be my sample for Bexley? Are those reasonable samples? Is everybody good? Yes, I'm realizing it. Had the wrong standard deviation there. Okay, is everybody good? So if those were the two samples I drew, my p-hat Grandview would be, I don't know, let's call that 0.72. And my p-hat for Bexley would be 0.61. Everybody good? So what would my measurement of the two be? I would subtract those two things. And so my difference would be 0.11, yeah? There's 11% difference between those two samples. But then let's go ahead and say,
Wait, why do we put Grandview first? Do we always just put the bigger?
it actually doesn't matter. That's a great question. When we, I'll draw both ways. At the very, very end, I can draw it both ways, okay? So that you can kind of see that what happens doesn't actually make a difference as long as whoever's grading your stuff is smart enough to know the difference. I am. Okay, but there's a matter of consistency that we want to think through. But for sure we can talk about it. No, it's like what happens is, let me go through. Ben, it's an amazing question. It's a really good question. We're not at a good spot for me to explain it yet, but I promise we will be soon. Okay, all right. So let's go ahead and say the green is one set of samples, and then we could get these two samples. Yeah, is everybody with me? It's very reasonable if somebody else takes two different samples from each school and gets totally different ones, yeah? So I might look at that first p-hat Grandview, and that one looks to be about 0.8, and p-hat Bexley is about probably about 0.7. Okay, so now what is the difference between my two p-hats? It'd be 0.1, because we would subtract them. And so when we describe this new distribution of the difference between the two, okay, if we're trying to find that, what we're doing, though, is finding this particular number for each one. So when we think about a point on our graph, what does that 1 point represent? It is a difference between two samples. Well, you guys, we've done some problems like this. So if I asked you, to do this subtraction between these two distributions. Are you with me that because both of these are normal, this one is normal? And when I subtract two normal distributions, the result's going to be normal. And so it's approximately normal. Okay, great. What about the shape of this distribution? What is it going to be? Or what about the center of this distribution? What is it going to be? On average, after I subtract, what should my differences average out to be? Thoughts? What do I do with means when I subtract two distributions? If you don't know the answer, you're overthinking it. You just subtract the means, yeah? Okay, so the mean of that new distribution will be 0.15. And the standard deviation of that new distribution, this is where we get a little hairy, would be the square root of 0.043 squared plus 0.034 squared.
I got 0.055.
Great. Okay. Now, Ben, now I'm slightly ready to address your question, okay? If I had done Bexley minus Grandview instead of Grandview minus Bexley, what would change about this graph?
Negative.
This would be negative, yeah? Okay, great. So this is p hat G minus p hat B. Okay. So if I did p hat B minus p hat G, this would be negative 0.15. Okay, great. So now if I say, would it be weird to get a sample where p hat Grandview was 78 and p hat Bexley was 52? Okay, you guys, what would be the value of p hat G minus p hat B in this scenario? It would be 0.78 minus 0.52, which is 0.26, yeah? So to calculate that probability, here's 0.26. If I want to decide, is something weird, the way I make the decision, is something weird, is I find the probability of that or more extreme, okay? So that difference is bigger than what we would expect, and so I would shade it to the right.
Would you 0.78 and 0.52?
That's the question?
Oh.
Okay? Now, if I wanted to do that on this graph, this is a graph of Bexley minus Grandview, yeah? So I would just, flip the order of those and get negative 0.26, which would be over here. And that's lower than what we would expect, so more extreme would be to the left. So when you see these two pictures, are you seeing that we're going to get the same answer either way, because they're the same idea, okay? So if you chose to subtract it in a different way, I'll see it. So I can look at this graph and know that this one is also correct. Does that make sense?
Yeah.
You will notice that I have lots of labels describing the direction of my subtraction, right? This one I'm telling you guys it's Grandview minus Bexley. This one I'm telling you Bexley minus Grandview. So like having those labels so you're telling me which direction you're doing that subtraction communicates what I need to know which graph which of these two graphs I'm grading you on. Did that answer your question?
I mean, I just know to subtract the bigger one, or just start with the bigger one and subtract the small one.
If there is a bigger one versus a smaller one.
Yeah.
Yeah.
Are there going to be any problems putting the negatives into a calculator? No, if we have to. Like, will it mess up the function?
I mean, you can put in a negative mean. So like your is like if I want to plug this one into normal CDF, I'll do negative a gajillion to negative 0.26 with a mean of negative 0.15 and a standard deviation 0.055. Like your calculator can handle it. It shouldn't be a problem at all.
So if we decide to go like Bexley minus Grandview, we should have to make sure we're consistent with that throughout like the problem.
Exactly. As long as you're but like the hope would be as you're going through it that you're going to be consistent because you're looking at the problem holistically in the first place. Cool? Great. Let's look at basic formulas and then we'll be done for today. Great. Wonderful. Okay, so basic idea. If I have, so these are the general rules for all of differences of p-hats. If I have, in order for two differences to be normal, I basically am doing that normal condition for the first group and for the second group. First we checked that Grandview's stuff was going to be normal, then we did that Bexley stuff was going to be normal. Is everybody with me on this? And because both those were normal, so it's basically you're checking that normality twice, one for each group. And then the mean of, and again, you guys see this subscript to describe what am I doing, which one am I starting with, would be P1 minus P2. Okay. You guys, essentially what we did before, we did the standard deviation of Grandview, right? Which was the square root of that squared. And do you guys see what I'm saying here? So the original standard deviation had a square root in it, and then I'm squaring it, and then adding it, okay? And then we had P Bexley times 1 minus P Bexley over N Bexley squared. But I don't know about you guys, but that looks too gnarly for me. You know, that's gross. Ooh, are you good with me saying this squared and this square root are going to cancel each other out? Is everybody good with this idea? Okay, so in reality, the standard deviation formula looks like this. P1, 1 minus P1 over N1, plus P2, 1 minus P2 over N2. And if you look, this should be on the back of your formula sheet, right under where the formulas yesterday were. or last week were. Yeah. Okay. And you're not going to worry about this column at all for Unit 5. We're not ready for it. Is that pretty good so far? All right, so how might I ask you about this? Meister estimates that 80% of of stat students complete work that she assigns outside of class. Turner estimates 72% of calc. Everybody good? You guys, these are totally made up. Okay? All right. Meister takes a random sample of 45 AP stats. Turner takes a random sample of 40 AP calc. Okay, so the first thing I want to do is describe the distribution. So imagine I take a sample of my students, she takes the sample of her students, and what we're going to do is we're going to say, well, blank percent of my students did their work outside of class, and she's going to say, well, blank percent of mine, and we're going to say who did more, and we're going to do this by doing stats minus calculus. Is everybody good? Okay, so before we worry about the description, can we talk through what are some of the important things we need to think through? Or what's the important information here that we want to write down?
The 45 students in stats and 40 calc students.
So are you cool if I write that as NS equals 45 and NC equals 40? What else do we know? So PS is 0.8, PC is 0.72. Okay. You guys, what are the important characteristics I need to when I say describe a distribution? Shape, center, and spread. So let's start with shape. We want to decide normality. How do I do that? So for stats, my NP would be 45 times 0.8 and 45 times 0.2. For calc, it would be 40 times 0.72 and 40 times 0.28. I think I already screwed up. So I think we get 36 and 9. And then it's 42 times 0.72, or 40 times 0.22, 28. Is it 28.8? And 11.2. So, will this be normal? Why not? The 9 is not greater than or equal to 10. Is the 9 close to 10? Here's what we're going to do. Not normal, but close to normal. And we're going to pretend it's close enough. Okay? Because I did a terrible job writing the question. Everybody okay? All right, what about center? This one's the easy one. What is the mean of p hat s minus p hat c? The standard deviation. What are we getting?
0.043.
Okay, you guys. So normal-ish, we're assuming. 0.08. Negative 0.05 would be down here. Is it reasonable that we could get a negative answer? What would it mean for p hat s minus p hat c to be negative 0.05? Because that's essentially what we're finding. Is everybody with me? So this would mean that stat students were lower in percentage in terms of completion, right? The difference between the completion rates between the two groups is more than 5%, where the stats class was lower. Is everybody good? And what is the probability of that? Since we know it's normal, that would be a normal CDF question. Just go ahead, throw this into normal CDF. What are we getting?
0.3.
Now, you guys for this one? 0.08? Cool. So is that surprising? Would you call that super unlikely? 8%? Somewhere between 1 and 10 and 1 and 20. I would put it at I would call 8% kind of like in the gray area of what is surprising versus what is I think 8% would surprise, something with an 8% likelihood occurring would surprise some people, not others, right? It's a gray area. Our typical rule of thumb for what is surprising, I would say, is about 5%. So I would say it's not super surprising. It wouldn't be kind of crazy. Typically we use about 5%. All right, now, without doing a single calculation, would 2%, what if I said, what is the difference, well, not 2%. Would it be surprising to get a difference that was less than negative 0.02? Well, negative 0.02 is like up this way more, right? Probably right about there. Would you guys be comfortable saying that would not be surprising? Because if the negative 0.05 is like, not surprising. Okay. I'm done for today. Did you guys get the homework? You got homework 5B, exit. Okay. I would say in terms of that homework, you can work problem number 1. And for the free response question, you might be able to do part A and part B. And then tomorrow we'll talk about sample means, and then you'll be ready to do